NASA's Pilgrim 1 spacecraft, which currently holds the record for the furthest distance traveled by any human-made object, has captivated people around the world for nearly 5 decades since its launch. Voyager 1 has provided invaluable data from the farthest reaches of space, significantly enhancing humanity's knowledge of the universe. However, the spacecraft's ongoing transmissions have recently encountered strange anomalies that have left scientists perplexed. These unusual signals have sparked intense debate, causing the scientific community to question whether these disruptions are mere technical malfunctions or possibly signs of something far more extraordinary, perhaps even evidence of extraterrestrial activity. Join us as we explore these mysterious signals and examine what might be hidden in the vast expanse of space. The innate human curiosity to explore the unknown has always been a fundamental motivator behind space exploration. This deep-rooted desire led to the creation of groundbreaking missions like Pioneer 1 and Explorer 2, which were among the boldest space missions of their time. On August 2, 1977, the launch of Explorer 2 from NASA's Kennedy Space Center marked the beginning of a new era in space exploration. Shortly thereafter, on September 5, 1977, Explorer 1 was launched, setting out on a journey that would eventually take it toward the outer planets, altering its orbit and influencing the outcome of its mission. The two spacecraft, each weighing around 720 kilograms, roughly the size of a small car, traveled in separate directions at different speeds. On December 15, 1977, a significant milestone was reached when Explorer 1 surpassed its twin in distance traveled due to the different paths they followed. Since then, Explorer 1 has become an invaluable tool in expanding our understanding of the universe, providing insights that have transformed how we view space. Before we delve into some of its more recent groundbreaking findings, let's first review some of its earlier major accomplishments. In 1978, while situated about 265 million kilometers from Earth, Explorer 1 successfully captured detailed imagery of Jupiter. By January 1979, the spacecraft had completed a remarkable 100-hour mission, producing a time-lapse video that showcased Jupiter's rotation. This collection of 3,750 images provided unprecedented views of Jupiter's chaotic atmosphere and intricate features. During this mission, the spacecraft also discovered a previously unknown ring surrounding Jupiter and identified 2 new moons, significantly enhancing our understanding of the gas giant's complex system. To ensure its safe journey and avoid potential collisions with Titan, one of Saturn's moons, the spacecraft conducted several correction maneuvers. Following this, the mission's focus shifted beyond the planets of our solar system, as the spacecraft was redirected toward interstellar space, traveling at an astounding pace of 325 million kilometers per year. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable milestones, including the discovery of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most iconic images of our solar system's outer regions. On February 14, 1990, at a distance of about 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning photographs of the inner planets. This collection of 60 images was added to the spacecraft's portfolio, which also included 670 photos taken during its flyby of Neptune. Explorer 2, on the other hand, also achieved impressive milestones during its mission. It recorded wind speeds that exceeded 13,100 meters per second, the fastest winds ever recorded in the solar system, providing scientists with essential data on Neptune's distant atmosphere and its moon Triton, which has surface temperatures plunging to a frigid -391 degrees Fahrenheit, making it one of the coldest places in the solar system. Triton also displayed ice volcanoes that ejected nitrogen gas and frozen particles up to 5 kilometers high, offering a fascinating new perspective on the moon's features. These extraordinary discoveries have greatly expanded our understanding of the diverse and dynamic environments in the outer reaches of the solar system. The contributions of both Explorer 1 and Explorer 2 have been groundbreaking, as their missions uncovered previously unknown details about the moons of Jupiter and Saturn, which were once thought to be inactive. These findings reshaped our understanding of the geologically active nature of these moons. In particular, Explorer 2 made history by becoming the first spacecraft to fly by both Uranus and Neptune, an achievement that has yet to be repeated. NASA employed various innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have devoted themselves to this extraordinary journey. The designs of Explorer 1 and Explorer 2 showcased cutting-edge engineering. These spacecraft were built to rotate slowly, minimizing image blurring as they traveled through space. Even before reaching the outer planets, the spacecraft began transmitting detailed images of Jupiter, revealing its swirling clouds and iconic Great Red Spot, a massive storm that has fascinated scientists for decades. However, the most exciting discovery came with the identification of active volcanoes on Jupiter's moon Io. The spacecraft's instruments detected unusual signals from the moon, which were later confirmed by images showing towering volcanic plumes and a surface marked by intense eruptions. One of Io's volcanoes erupted with a force 1,000 times more powerful than Mount St. Helens, covering an area nearly as large as France. As the spacecraft continued their journey, they were eventually powered down to conserve energy before beginning their voyage into interstellar space. Remarkably, the images they captured did not include Mercury or Mars, due to technical limitations. NASA later launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the farthest spacecraft from Earth. Despite this, Explorer 1 continued its solitary journey for an additional 14 years before finally entering interstellar space on August 25, 2012. The success of these Explorer missions was largely due to the innovative use of gravity assist maneuvers, which helped propel the spacecraft to their destinations while conserving fuel. Rather than relying solely on their propulsion systems, the spacecraft employed gravity assists, utilizing the gravitational pull of planets to increase their speed. This technique allowed them to cover vast distances without depleting their fuel supply. As Explorer 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Precision was essential to avoid catastrophic deviations in trajectory or speed, and these maneuvers allowed the spacecraft to navigate its journey through the solar system and beyond. Similarly, Explorer 2 utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune, demonstrating the efficacy of this technique. Reflecting on the immense accomplishments of these missions, we eagerly await further insights into the recent anomalies detected by Explorer 1. The Voyager spacecraft continue their missions beyond the known limits of our solar system, exploring the mysteries of Jupiter, Saturn, Uranus, and Neptune. Explorer 1's time-lapse images vividly captured 10 eruptions on Jupiter, in addition to revealing new moons and a previously unknown ring surrounding the planet. These discoveries have greatly advanced our understanding of Jupiter's system. Similarly, Explorer 1 identified 4 new moons of Saturn: Mimas, Enceladus, Tethys, and Rhea, and captured beautiful photographs of the planet and its rings, offering fresh insights into its complex system. The spacecraft's groundbreaking visit to Uranus and Neptune provided valuable data on their environments and moons, enriching our knowledge of the outer solar system. Following their planetary missions, both Explorer 1 and Voyager 2 set their sights on interstellar space, where they continue to collect invaluable data. This ongoing research is expanding our understanding of the universe beyond our solar system. As we await more details on Explorer 1's unusual signals and their implications for our understanding of the cosmos, the remarkable journeys of these spacecraft continue to inspire awe and wonder among scientists and space enthusiasts alike. Their achievements persist in advancing our collective knowledge and pushing the boundaries of space exploration. The Voyager missions have granted us unparalleled insights into the solar system and beyond, offering iconic images and scientific data. Along with these discoveries, the missions also carry a message, an artifact designed to communicate Earth's story to potential extraterrestrial civilizations. The Golden Record contains greetings in 55 languages, music from various cultures, and sounds of nature such as thunder and whale songs. This message in a bottle represents humanity's hope that one day, intelligent beings beyond our world may find it and understand our essence. Explorer 1 and Explorer 2 were equipped with a variety of scientific instruments that revolutionized our understanding of space. These included magnetometers, plasma wave detectors, and imaging systems, which provided critical data on space phenomena. For example, the magnetometers offered valuable insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the interactions between these planets and their environments. The plasma wave detectors helped us understand the behavior of solar wind and its effects on planetary atmospheres. One of the most remarkable achievements of the Voyager missions was their ability to measure the heliosphere boundary, a region filled with solar particles and magnetic fields that surrounds our solar system. As Explorer 1 approached this boundary, it detected a shift from solar wind to the interstellar medium, providing crucial data about the structure of the heliosphere and its role in shielding Earth from cosmic radiation. The spacecraft revealed a distinct boundary known as the termination shock, where solar wind slows down and becomes denser. Beyond this boundary lies the heliosheath, where the solar wind interacts with the interstellar medium, creating a dynamic and complex environment. Explorer 2's journey has also contributed immensely to our understanding of the outer solar system. Its flybys of Jupiter, Saturn, Uranus, and Neptune provided vital data, particularly its observations of Uranus' magnetic field, which was found to be tilted in a way that challenged existing models of planetary magnetism. These discoveries have sparked further investigations into the magnetic fields of other planets. These missions have not only advanced scientific knowledge but have also ignited public interest in space exploration. The stunning images of distant planets, coupled with the personal stories behind the spacecraft's missions, have inspired millions worldwide. The breathtaking photographs of Saturn's rings and Jupiter's volcanic moons have become iconic, motivating the next generation of scientists and explorers. As we continue to study the data sent back by these spacecraft, the ongoing exploration by Explorer 1, Voyager 2, and other space missions continues to push the limits of human knowledge. Each new discovery uncovers new mysteries, motivating scientists to rethink long-held assumptions about the universe. The most recent findings from the spacecraft have the potential to reshape our understanding of fundamental aspects of space itself. One of the most significant aspects of these missions is their role in expanding humanity's ability to comprehend the complexity and vastness of the cosmos. The data sent back by Explorer 1 and Voyager 2 have revealed not only the nature of distant planets and moons, but also provided valuable insights into cosmic phenomena such as the behavior of interstellar particles, the effects of radiation, and the dynamics of solar and planetary magnetism. These insights are essential as we look toward the future of space exploration, where the next generation of spacecraft may one day venture even further into the unknown. The mysterious anomalies detected by Explorer 1, particularly the unusual signals recently transmitted, continue to spark curiosity and debate. These unexpected transmissions have opened up a new realm of speculation. Could these signals be the result of malfunctions in the spacecraft systems, or might they be something more extraordinary? Potential signs of life or even signals from other civilizations. As scientists work tirelessly to analyze and understand these signals, they are reminded of the challenges and surprises that space exploration often brings. It is a reminder that, in the vast and unpredictable universe, we are still at the very beginning of our journey toward understanding what lies beyond our solar system. While the prospect of discovering extraterrestrial life remains one of the most exciting possibilities, the current focus is on deciphering the strange signals from Explorer 1. Researchers continue to refine their methods of detecting and analyzing these signals, using sophisticated algorithms and computational models to separate possible noise from meaningful data. As we await the resolution of these mysterious anomalies, the sense of wonder and possibility remains alive in the scientific community. Beyond the signals, the missions of Explorer 1 and Voyager 2 also carry profound philosophical and existential implications. As they journey through interstellar space, these spacecraft serve as humanity's emissaries, carrying our story across the stars. The golden records aboard these spacecraft, designed as a message to any potential extraterrestrial life, reflect our desire to communicate with others in the universe. This is a bold and hopeful message, a reminder that, as a species, we are not just observers of the universe but also active participants, sending out our own messages into the void, hoping to make contact with anyone who might be out there. In addition to the gold records, the scientific instruments aboard these spacecraft have provided humanity with priceless data on the physical conditions of distant worlds. For example, the detailed imagery and data collected by the imaging systems have not only provided us with beautiful photographs but have also given scientists crucial information about the surface composition, atmospheric conditions, and weather patterns of distant planets and moons. These findings have implications for the future of planetary science, helping us understand how other planets may have formed and whether they could potentially support life. The discoveries made by Explorer 1 and Voyager 2 also have implications for the future of human space exploration. As technology advances and humanity prepares to venture beyond our own solar system, the lessons learned from these missions will guide future expeditions. The spacecraft's use of gravity assists, as well as their ability to operate in the harsh environment of deep space, will inform the design of next-generation space vehicles. The data they have collected will also help scientists plan for future missions to other star systems, guiding efforts to explore exoplanets and even consider the possibility of interstellar travel. As we reflect on the legacy of these missions, we must also consider the incredible technological advancements that have made them possible. The development of powerful propulsion systems, advanced imaging technology, and highly sensitive scientific instruments has enabled us to explore the farthest reaches of our solar system and beyond. These technologies continue to evolve, and the future of space exploration looks brighter than ever. With each new mission, we are learning more about the universe and ourselves, and the sense of wonder that has driven humanity to explore the stars remains as strong as ever. Looking to the future, there are countless opportunities for further discoveries and breakthroughs. Scientists are eagerly awaiting the next generation of spacecraft that will carry our understanding of the universe even further. With more advanced instruments, improved propulsion technologies, and new methods for analyzing data, we can expect even more exciting discoveries as we continue our journey into the cosmos. In the coming decades, missions like those led by NASA will likely take humanity further than ever before. Whether these spacecraft explore new planets, capture images of distant stars, or detect signs of alien life, the possibilities are endless. Just as Explorer 1 and Voyager 2 changed the way we think about space, future missions will likely redefine our understanding of the universe in ways we cannot yet imagine. As we continue to push the boundaries of space exploration, we remain hopeful that the mysteries of the universe will one day be unraveled. The quest for knowledge, driven by the same curiosity that led to the creation of Explorer 1 and Voyager 2, will undoubtedly lead to even more profound revelations in the years to come. Whether we find new worlds, new forms of life, or new ways to understand the nature of space itself, the journey of discovery is far from over. With every new mission, we come closer to answering the most profound questions about our place in the universe. And perhaps one day, we may even make contact with the very beings we've long wondered about. In the meantime, the extraordinary journeys of Explorer 1 and Voyager 2 continue to inspire generations of scientists, engineers, and space enthusiasts. Their legacy is not only one of scientific discovery, but also of human curiosity, perseverance, and the belief that there is always more to learn, no matter how far we travel. These missions remind us that our exploration of space is not just a technological achievement, but a deeply human endeavor that speaks to our innate desire to understand the world around us and our place in the cosmos. As we continue our journey, we remain hopeful that the answers we seek are out there, waiting to be discovered.